All right, so we're going to talk about arc length. And suppose I have two concentric circles whose arcs are subtended by the same angle. Their respective arc lengths are proportional to the radii. Very simply, let's work through that sentence again. Two concentric circles, that is the same center, concentric, whose arcs are subtended by the same angle. So my diagram here is there's an arc that is subtended by theta. Here's another arc subtended by theta. The respective lengths of their arcs, the respective arc length, the length of the blue and of the yellow, will be proportional to the radii of the circles, which I will draw again in yellow and in blue. All right. So let's consider the special case where one of the radius of our circles is 1. Given the property above, we can create the formula A is equal to theta r, where A is the arc length, theta is the angle in radians, and r is the radius of the circle. Very straightforward formula. Now, let's go over this example here. Brian wishes to circumnavigate the world. After 2 years, 13 days, his path has a central angle of 37 degrees. The radius of the Earth is estimated to be 6,371 kilometers. How far has Brian traveled so far? What does this mean on the picture? Well, the picture means here's Brian. He started maybe right here, and he's walked or sailed all the way over there. I'll use white, something a little bit more permanent. That angle is defined, so from here to here is 37 degrees. How far has he traveled? Well, we have this beautiful formula. A is equal to theta r, where A is the arc length, and that's what we'd be after, right? It's the partial circumference of the Earth, where theta is an angle in radians, and r is my radius. Now, really important to note that my central angle is given in degrees. So therefore, this formula will not work. If I could somehow change degrees into radians, I would be in business. Let's maybe move on to that very property. Conversion between degrees and radians. So I will revisit this example, but let's do this. There are several ways to convert radians to degrees or degrees to radians. A good place to start is to acknowledge that a revolution of a circle is 360 degrees, or 2 pi. Now, recognize that 2 pi and 360 degrees are one full revolution of a circle. However, there are two ways of saying it. One's in degrees, one's in radians. Half a revolution, now this is the one that's more valuable. We could also say that half a revolution, 180 degrees, is equal to pi. You have experience with this. This is called conversions. You convert stuff all the time, I believe. For instance, American dollars to Canadian dollars to pesos. We convert a lot. And it's either constantly asking yourself, well, do I multiply by a certain number or do I divide? Well, that's oversimplistic. So let me take a look at this. I'm going to call this a conversion factor. Did you know that pi over 100, pardon me, it jumped on me there. Pi over 180 degrees is a special type of 1, right? A quantity divided by itself is essentially 1. Now, a half revolution divided by a half revolution, this is 1, but it's a special type of 1, right? It's not 1 numerically, it's 1 in concept. So we're going to be using these conversion factors to help us out. So conversion factor. I am going to convert pi over 8 into degrees. So what I'm going to do is I'm going to multiply it by 1. However, I'm going to change the units of this. What is the one I'm going to use? I have two choices, pi over 180 or 180 over pi. Sorry, let me say that again. Pi over 180 degrees or 180 degrees over pi. So really, what would I like to do? I would like to convert this into degrees. So my final answer should have degrees as the unit. So that gives me a very strong indication that I have to multiply this by 180 degrees divided by pi. Now, it's not a matter of converting or dividing out pi. Rather, it is simply asking yourself, it is really simply asking yourself, what unit do I want? And since degrees is in the numerator, my final answer is going to have degrees. So what we notice, we have a factor of pi in the numerator and denominator. Those cancel each other out. So I'm left with 180 degrees over 8. And if I divide both top and bottom by 4, I end up with 45 over 2 degrees, or 22.5 degrees. Now it's set as an exact value. All of these are exact values. Probably this might be a little bit hard for you, but let me just take an intermediate step here. If I divide the top by 2, if I divide the bottom by 2, and do it once more, would be on track here. All right. There's my final answer, expressed exactly. So that's expressed exactly. So now I'm going to figure this out as a ratio. So I'm going to convert pi over 8 into degrees for a ratio. Now, I love ratios, but here, apple is to apple tree as orange is to orange tree. What? I know it's a goofy saying, but it helps me set up a ratio. Apple is to apple tree, sorry, that's now true, as orange is to orange tree. So really a ratio is you set up two ratios and equate them to each other. And there should be some beautiful, beautiful symmetry about them. That is, in the numerator, what do you notice? Well, in the numerator, apple is to apple tree as orange is to orange tree. Well, in the numerator, we're talking about fruit. So those are common things. Now, in the bottom, we're actually talking about the trees. All right? A lot of you guys are probably looking at your computer screen perplexed. On the left-hand side, I'm talking about everything that has to do with apples. On the right side, this is everything to do with oranges. Ratios are set up with this beautiful idea of symmetry. There's 3 different types of symmetry there. So I'm just going to get away from talking about fruit, and I'm going to talk about angles. Generally speaking, we like our unknowns to be classified as x. So I'm going to put equals, and pi over 8 is a partial angle. So I'm going to put degrees on one side and radians on the other. And I'm going to say a partial revolution in degrees is equal to pi over 8. Now, half a revolution in degrees is 180 degrees. In radians, it would be known as pi. On the left-hand side of the equation is everything to do with degrees. On the right-hand side is everything to do with radians. On the numerator, we're talking about partial revolutions, and on the bottom, we're talking about half revolutions. The power of the ratio is incredible. So I'm going to multiply both sides by 180 degrees. So this is 180 degrees times pi over 8 divided by pi. And if I do that, what I get is x is equal to 180 degrees. Make sure you keep that unit divided by 8. And just as we saw before, x is going to be 45 degrees, or 45 over 2 degrees. I'll be honest with you, very few people like ratios. Don't need to do the ratio. However, you're probably finding stoichiometry a lot easier if you like ratios. Now, we are going to convert, the next example, by the way, we're going to convert 33 degrees into radians. So express our answer as the approximate value, rounded to 3 decimal places. So I'm going to use the conversion factor, and then I'm going to use a ratio. So the two conversion factors that I have to deal with are this, right? It's either pi over 180 or 180 over pi. So if I want to change 33 degrees into radians, what I need to do is I need to multiply it by pi over 180 degrees. What would happen, now if you notice, I have the unit of degrees in the numerator, and in my conversion factor, I have degrees in the denominator. Recall that radians is actually unitless. So simplifying this, I get 33 degrees, or 33 pi, divided by 180. I can divide out my degrees for units. And by the way, I said approximate value. I'm just going to, since it's easy money here, I'm just going to say exactly written. I can reduce both top and bottom of the denominator by a factor of 3. So if I can divide both numerator and denominator by 3, this can be written exactly as 11 pi over 60. However, if we write it in as an approximate value, I'm going to take out my calculator, and I have 11 pi divided by 60. Now, it's really important that in your calculator, you use, so you can calculate this part in your calculator, but please use the symbol pi. And what I get is in radians is that theta, or whatever this angle is 0.576. That's my angle. Now, I'm going to calculate this with the ratio, the power of the ratio. So remember that one side is going to be degrees, one side is radians. That's how I like this symmetry. In the numerator, I'm going to have partial revolutions. Basically, what am I being asked? Well, I'm given 33 degrees. 33 is what in radians? I have no idea. Let's call that x. Now, in the denominator, I'm going to go with partial revolutions. Well, if in degrees, a half a revolution would be 180 degrees. In radians, this would be pi. So now, very simply, I'm going to multiply both sides by pi. So I get x is equal to 33 degrees times pi divided by 180 degrees. The unit of degrees cancel each other out. So I'm left with x is equal to 33 pi divided by 180. And I can calculate that in my calculator. And what I get is this decimal, but rounded to 3 decimal places, it is definitely going to be x is equal to 0.576. There we have it. There's converting radians into degrees.